Hello everyone. Okay, how are you feeling today? Okay. Feel lazy?
Acceptable.
Yeah. Well, if you want like perhaps tips from me, I'm not going to give you advice like, okay, study hard, work hard, blah blah blah. I think that's too cliche. It's not really, not really, not really brilliant. I mean, people always says that you need to work hard, study hard to get success, but I don't think that is sufficient. You need to have another perspective, I believe. And I think most innovations, like I think 10 years ago or perhaps 15 years ago, it is really difficult for you to like purchase something online, like maybe using your like Food Panda or Uber Eats. Now it's everywhere. Everyone going to digital world. You know why? How? Because people want to pleasure themselves easily. Like when you sleep, you can order food. Oh, the food is coming. So I think being lazy is not really like it's not really that bad, as long as you know how to make it smart. So lazy is I believe being lazy is it's okay for me, as long as you're smart. If you're smart, then you can find a way to work efficiently, effectively. Like study like from maybe 4 hours, 20 hours. I think it is crazy 20 hours. Maybe 10 hours study. I think it's too much. It's too much. Your brain needs to have sometimes they need to relax. They need to rest. And you also need to exercise yourself. And then you need to also socialize, have friends, entertain yourself, playing games. I think games is, I think you already have in your phone right now, easily, right? So when you're bored, you can play games. You can like take some time to like scrolling your social media, right? But you need to balance all that line. Okay? When you study, when you sleep, when you exercise, when you play, you need to balance that out. And I will not really like if you're lazy. I will not be angry or mad. But promise me, you will do smart. Okay? You will do smart. Being smart means it's not. It's different. Smart with the like cunning. Cunning. You write a word. Maybe you can find the words, and I don't have other words that easily to express them. Like cunning. Sometimes it's good. Sometimes if it is way too much, you will get yourself to the dark side. if you watch Star Wars movie, you will get to the dark side and you will become the Sith. Okay. Anyway, I don't mean being smart is going to that direction. Okay? You need to also keep yourself integrated. Okay, integrated, being honest and etc. Okay. Aside from my pep talk, this is last discussion. I will finish off this part a little bit. Maybe one more example, then we'll find, and maybe give you 2 more problems just to set off this related phrase. And after that, we will have some practice to review what we have done. And then at the end, maybe around last 40 minutes, we are going to new sections after this related phrase, which is called the linear approximations. Okay? Which I believe the linear approximation will bridge us to new chapter, which is the application of derivative. So let's start with going through the example. Okay.
Let me go through the new page and edit. I think this one. Okay. Maybe make it bigger.
If you look on your textbook, I think you will have different units, but I believe the same problem, but different units. But how the process is should be the same. It should be the same process, should be the same idea. So first thing to help, if you don't familiar with the terms or any English, you can read sentence by sentence. So first sentence is a man walks along straight path. So there is a man and he walks. He walks straight, and the man has fixed speed 4 feet per second. And then the second sentence starts with the spotlight. Spotlight located on the ground 20 feet from the path. So you can just draw a path and then maybe put the light maybe here, 20 feet. And then the spotlight is shining through the man because it can't focus on the man. And then the question, at what rate the spotlight rotate? So spotlight you can rotate, right? So if you remember physics, the rotation also can have a velocity, right? And then when the man is 15 feet from the point of the path closest to the line. And remember, every time the questions ends with some numbers or information, we are not using this yet. So we are going to process the formulation first. Take some time to derive with respect to t. Always with respect to t. That's the related trace, always with t. And then at the end, we are going to put the 15 feet to our formulations. Okay? So we are going to find first, maybe the first thing we need to do is to draw. Okay? That's very, very intuitive, very obvious. That it should be understandable if we have the drawing. Right? So maybe sketch first. We can sketch the drawings.
So maybe to imagine, maybe there is a man. Okay. And then he walks. Let's make another. Okay. And then maybe the spotlight is around here to make it easy. Okay. And then we set this distance. Let's say this is 20, right? 20 feet. And then we can also give some variables. Maybe the distance, I think you can use x, a, anything. Maybe x, okay, x. So the man is actually maybe going from here, going there, right? And then we know, okay, this is a 20 feet man from here, from the spotlight. And it goes through here, and the spotlight will follow the man, right? So the question is asking the rate of when the spotlight is rotating at this 50. So let me write x for the distance. Let me write x. So we are going to have dx over dt 4 feet per second. Okay.
So in every problem for related rates, usually they will only have fixed rate. Of course, if the speed is changing, it will be very difficult to take on with the related traits process. So always they will have simplified velocity and then simplified formulation. Okay? We don't really think about another factor. Okay? Maybe this man, the speed is changing. Maybe when he walks, he feels tired and he will stop for a while, and that will be very difficult to imagine. Right? So we keep simple. We keep simple. Okay, dx over dt 4 feet per second.
So if we want to focus on the rotations, the best way to think is, maybe let me draw this as a triangle. Okay.
So if you want to think about this rotations, then the best way is to see the angle, right? To see the angular rotations.
So we are going to have our theta here. Okay. So actually, the question is asking d theta dt when the man is 15 feet, when the man is 15 feet from the point on the path closest to the light. So when, I think we can say this is x equal 15. So this is the question. Okay.
Now first, every time the question asking about anything related to rotations, or maybe directly asking about angle, we are going to see relations between angle, sides, or maybe these sides also, but I think we just keep simple, just 20 and x, and I think the best way to relate this theta is maybe tangent, or maybe cotangent, but perhaps tangent first.
More familiar with you, right? So we could say the tangent theta is x over 20. Or we can write x as 20 tangent theta. And then we differentiate with respect to t. So we are going to get, this will be dx over dt equal 20. What is the derivative of tangent?
Sec square.
Squared, yeah, squared. Don't forget the squared. So secant squared theta, d theta dt. Okay, now,
Now we are going to find this d theta dt, right? dx over dt we have. Now how about the secant squared theta? We get this from when x is 15. So we are going to find the theta when x is 15. So we need to calculate the Pythagorean first to find what is theta, or what is this secant theta.
so we can write down when x is 15, you can draw the triangle. So this is 15, this is 20. Secant is 1 over cosine, so we can, well, to make it easy, maybe start with cosine. Cosine theta is, what is this? This part? This is 400 and 225. It's 25, right? Is it correct? Right, correct. So what is cosine? Cosine is 20 over 25. So secant is 25 over 20. Or we can say this is 5 over 4. Or actually, we could just change with one of another. So we are going to put 4 here, and then secant 5 over 4 here, and then this compute. So we are going to have 4, 20. This is 5 over 4 squared, and then d theta dt. So we will have what will be 16. So d theta dt is 16 over 25, and 5 is 125. So this will be radian per second. Oh, by the way, about every exam or every quiz that I've prepared, especially for the new platform, please pay attention to the instructions. I think at the beginning I'm telling about how to write something that is supposed to be fraction or decimal. Please write in the fractions, okay? The closest fractions that it will have. Okay? It will help me to notice. Okay? Well, of course, I will check. Well, sometimes you forget, but I will always check one by one, because I think a few students write in decimals, but it's correct. So I adjust this score. So if you feel the score maybe getting low and maybe you feel it should be correct, your points is I'm already adding the points. Okay, let me go through some examples. But I think if you want to write down as a note, I can wait for a minute. Okay, let me give you with start with the example here. So we start from the simple one, and then maybe we'll have another two later, two more examples. It's similar to what we had yesterday. So something like a tank, and we fill with water. And I believe if they provide you with the units, I think it will help you to justify your results. If it's in meters, so you will have a meter in height. Give you the one for a couple minutes to try. So it is a cylindrical tank, so a cylinder. And I hope
you know a cylinder thing. Every volume, volumetric like shape, the base formula is for volume is always the area of the base multiplied with the height. That's the common. To make the calculation, every calculation simple, do not calculate the pi, just leave pi as pi. And if it's fraction, just leave as fraction. Do not put the thing. That will be simplify your calculation. Yeah, just like this one. Yeah, I think it's pretty simple. Yeah, pretty simple. Yeah. It is the simple one.
Okay. Okay, this is actually really simple because the radius is not changing, it's fixed. So it's a constant. The one that changes is just the level of water, right? So we just need to plug in the radius first. So let me write the formulation. So the volume is pi r squared h. Okay. Let me write here to give you note that the radius is fixed at 5 meters. So we could change this with radius of 2,5 pi h, and then take derivatives. And this will be 25 pi and then the h over dt. So dv over dt is our volumetric change, right? 3 meter cube. So this will be 25 pi dh dt, and that's why the dh over dt, the height, will be 3 over 25 pi meter per minute. Okay. So I believe one important thing here is to identify which one is changing, which one is fixed, which one is constant. You guys have chemistry lab this morning. How is it? Is it okay? Or higher? Not really. the result.
Yeah.
Yeah, and there you need to find the molar mass.
Yeah. It's supposed to be 60 and I got 100 something.
I think that's okay.
Yeah.
It's okay. Still okay. So. There are a lot of factors if you think on laboratory, and usually human factors is the most common cause.
Somehow.
Okay,
It's not my field of research, bro.
let's check another one. Let me.
I think I will adjust results later on the poster.
Hmm.
Yeah, of course.
Okay, let me put the new page. I think this. There are two questions here, but I think yeah, I think we can try both, and we can review and move on to new sections. So this is question 1. This is question 2. You can start from one first, from the Ferris wheel. You need to carefully read and understand. 1 revolution? Yes, full circle, 2 pi. 1 revolution means 2 pi. So let me guide you how to understand the question. Okay, if this is an exam, I will give you the picture to have. So a Ferris wheel is rotating, right? So it has the radius. Of course, the radius is not changing, right? If it's changing, it's going to be a mass. The radius 10 meters is rotating. It has rate 1 revolution. So full circle for 2 minutes. So it will go 2 pi for 2 minutes. So you have radius per minute. Okay, get it? Yeah, radius per minute. I think we can just use minutes to simplify. Don't change it. We will have different value. How fast is a rider rising when his seat is 16 meters above the ground level? So you can imagine it's moving, and it's asking how fast it is when it's going up, and then when it's up, at certain point we will have some certain height that is 16 meters. Okay. And it's asking how fast it is. You can name your variable, age, x, y, anything. So we need to have, maybe let me draw for you. Okay, let me draw. So let me draw first is the situations. Okay, the situations. So we have a Ferris wheel. So let's say this is the seat. Let me draw for some seat. Okay. The other part is just and it is the 10 meter, right? So let's say this will be some certain height, okay, on here. Well, you can name this anything. I will name this the height will be, let's say, h. Or perhaps to make it easy, let's just name this h, because the ground level is 16. So maybe let me name the h here. The h until here, and we will have another one that is let me write with red color. Oh, so there will be another one here. This was the one that will be 16. I think we can write this as 16. And of course, this is also the same 10 meter because of the radius. Okay, I think we have all we need. Oh, I forgot to mention the angle, the theta. So if we have h here, it's asking, where's the question? This is for number 1, sorry, number 1. Okay.
So how fast is a rider rising when his seat is 16 meters above the ground level? So it's actually asking how fast this will be. So if I take this h, make it simple because I want to formulate this h with the triangle, this triangle. So we are going to look for dh over dt. We are going to look for dh over dt. Well, the 16 is just to note that we are going to have the seat is 16 above ground. So the ground, let's say the ground is here. And of course, we are going to simplify the problem. We are not sure if there is another height like the Ferris wheel, but we can just assume if we just simplify it.
Okay, the first thing is the revolutions. So one revolution is 2 pi. So every 2 minutes. So the radian speed we can take radian per minute. So we have pi radian per minute for the d theta over dt. Okay. That's the meaning for
the revolutions. Okay, now from the formulations, we have h, we have 10, and we have theta. So we can take trigonometry, right? Trigonometric sign. So every time you have taking the maybe angle, I think one of the best ways is taking the trigonometry. Sometimes the calculations maybe will be better if you take the inverse trigonometry. Sometimes, but for this case, I think the trigonometry will be the best approach. Okay?
So sine theta, or maybe let me draw first the triangle to make it clear what we are going to find. This is the theta, tan and h. So sine theta is h over tan. We can write h is tan sine theta.
And the one we need is dh over dt, right? From the question, how fast the rider rises. Right? So we take the derivative with respect to t. Okay.
This will be tan cosine theta and d theta over dt. Okay, now we have a problem again.
We have cosine here. And I hope you already see the pattern here. I hope you already see the pattern. Do not be intimidated with the words, with how they approach the question with the questions. But the previous questions that I give you, or in the examples, like we have 5 examples, we will always end with something that, okay, we need to make sure that we get this from the information. We will get the cosine theta from the 16. So we fix the 16. We have tan here, radius. So this will be 6. Okay. So when it's 6, it's 10, and it should be 8, right?
So when let me write, when rider is 16 meters above the ground, h will equal 6, and let me write this is, let's say, x, and x is 8. Okay. This is from 10 squared 6 squared plus h squared, not h, x, sorry. So x is 8. And cos theta, we can write 10 multiply with 8 over 10, and then this will be pi. So we will get 8 pi meter per minute.
Okay, any questions first? Any questions? I think the difficult problem in the related rate is how to visualize and imagine the questions work. I think that's the difficult part. I think the process, how to compute, usually not too difficult. I would say it's relatively easy for the process. But for understanding the question, that is difficult. To imagine how the structure, how the drawings, that will be very difficult. And I believe you need some clue or hint for questions. I will provide you later with, I think, perhaps homework, maybe 6, 7 questions on chapter 3, and hopefully it can help you to, at least if I give you this practice,
this exercise. I'm not sure how you progress, but I'll give you homework. You will submit something to me, and I can know. Okay, you get it. Okay, for number 2, I think I will give you as a homework. Okay, we can look up later, and I will give you the how the diagram how it looks like, because you will have. I believe this will be you have a plane. Usually, a typical question like a plane, a man walking, and then it has some angle. You will feel that, okay, I might need a triangle. And it is. You will see every question that has plane, angle, or a man walking, angle, ladder, angle, you have triangle. Okay, so I give you some clue on how to solve that. Okay? And a car going north, going west, or going south, and blah, 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 also triangle. Aside of that, perhaps the area changing, volume changing, need to use the formulation for area or volume of that shape. Okay? And it will always repeat, and the pattern is always the same. The pattern is always the same. Okay? So do not be intimidated with the questions. Rather, finding the pattern. Okay? Finding the pattern. That is the best way to understand this. Okay, let me start with some review on what we have done in the couple weeks, at least the differentiation rules, the techniques. Let me give you some questions, and we can start with that. So let f of x equal and also the question from the last time, this one. Okay. I will explain again. Maybe we start with the first one here, and I will explain yesterday feedback question. I hope you still also remember pattern in differentiation. And I believe when you master the pattern, you will know how to identify most of the questions in the review. Okay, first look up the question. It is a function with power of another function. Okay, I already give you some suggestion when you have a function and the power of a function. The problem is you have a power here, right? Can you directly derive this? Can you directly derive? That's the first question. You need also to think when you give some question like an exam. First thing you need to think: can we directly derive that? Okay, remember, I gave you the
techniques from the simple one like power rule, product rule, quotient rule, and then the complicated one, the chain rule, the what else? The implicit differentiation, right? And then the logs, also the inverse of trigonometry, right? Well, we need to justify ourselves which method that we need to take on this functions here. Okay. Remember, functions with power of functions. What's the best way? Let me give you a couple of minutes to think. Yeah, yeah.
You mean how to find derivative?
Yes, yes.
Find the common derivative for this function and then just substitute the e.
Yeah, that's basically the question. Find the first derivative and put e inside. Kalau dia bentuknya sin sendiri juga sama juga. Have a break. After the break, we can go back to this one. Okay, we are going back to this question. Okay, let me give you some advice, tips. Every time you see a function as a power, what you need to remember, okay? So let me just give you an example. If you have like x with power of x, there is no direct derivative formula for this. The only way you can do it. Okay? And also whenever you find something that is complicated, maybe complicated at the power, one thing you need to do is you can add the ln, okay? And then when you have this, you can write, you can move this x, okay? Because of the logarithm property. And then you can take the derivative. And we can do the implicit and then we can solve y is x power of x, and then 1 plus ln x. Okay. Now, same way with when we did our questions, we are going to put ln. We're going to put ln the idea is just to make the power going down, okay? Because when we have this, it's much simpler, okay? It's much more easier to compute the product rule, right?
So I think we can do that. We can do here. So let's write in terms of y equal ln x sine x, and then add ln both sides. So we will have sine x, then ln, and then ln x. Okay. And this will be a product rule, right? When we take the derivative both sides. This will be 1 over y, and then dy dx, or we can write y prime. And let me take this as fg, okay, just to note which one we need to derive. So cos x ln x, okay, and then plus sine x. And if you're not really confident to derive that directly, well, we can just write d dx first and then ln x. And I suggest you do the same thing if you are not confident to derive directly. Okay? Just take your time to learn and becoming more familiar with the process. Okay? And we can bring this to another page, and you can compute that first. If you don't want to make this mess, okay? It also helps sometimes, because if you have too many equations in one page, maybe you will have some confusion. So you can take sometimes to compute in the separate equation. That will be I think very good for compute. Okay, so let me write here. So if I have y ln x, then y prime is, remember, ln with something here. Let's say if you also still confused, take this as a or anything. So this part will going down, right? 1 over this part, and then multiply with the chain rule. Okay? We derive this. So we are going to have 1 over ln x multiply with 1 over x. Okay? So 1 over y, or y prime. Let me write 1 by 1. This will be over ln x, and then 1 over x, like that. Or I think we can directly just write x ln x here. I think that's supposed to be the same. And then we can input the e. Okay, we can input the e. Now, because we have also 1 here, I think we need to also compute fe. So let me write here. If we put fe,
we put here, what will be? We have
what? 1 power sine e. Well, let's say we have that. Okay, let me write here. So we take this and take 1 over y prime, cos e ln, this is 1, right, ln e, plus sine e over e. I think we can just simplify this just to be 1, okay, to make it clear. So y prime is, or maybe let me write here. So y prime is, because this will be 0. So this will be y multiplied with sine e over e. Y is 1, so this will be sine e over e. Okay. Yeah, this is one of, I think, I forgot which exam is this, but this is, I think, 1 year or maybe 2 years ago, one exam. Well, of course, in the exam, you will find some not too complicated, some is, I think, quite easy, right? Need to be balanced, right? Just to check your.
Why don't we consider 1 over y? Why don't we consider 1 over y? Why don't we count this?
Because 1, right?
It's 1.
Right. Here.
Oh.
Okay.
Yeah.
Yeah. So y equal 1. Okay. Okay, if you would like to take notes. So every time you have a functions, power with another functions, best way is to start with the power going down, like taking the log or ln. One over y is we need to consider because this is 1. If it's different number, so we need to multiply with that number. Okay. This is actually let me write. Oh, it's so this actually y prime y since ye is 1. Okay. One with power any constant is 1. Oh. Right? Except if that is maybe not a constant, well, it will be different case. And we will count that later. There will be another section, and then still be limit problem also. Okay, any other questions? Any other questions? Okay. But I hope, okay, I think every student has their own limit, right? I mean, you guys have your own, like, positive or negative, right? I hope you know yourself, okay? Which part that you need to learn, which part you need to maybe you need to train. Like, I will move on, like section per section, but you need to know which part on that section that you need to still maybe train over. Okay? So if you know which part, I think it will help you to study. If you don't know which part, I think it will be very difficult. Okay?
very difficult to move on. So you need to know your own weakness. Okay? You need to know your own weakness. This is also helpful if you are doing some exam, any exam, physics, chemistry, most of the exact science. If you know this, then you can optimize your results. Okay? Like for example, you have like 1 to 10 questions. Sometimes we like naive students, okay, try from number 1, and then you stuck. And you stuck for some time. You waste your time. Scan through the question. You will find some question that, okay, I think this is easy for me. Take that first. Will be helpful. So you need to know your own limit, your own weakness. Okay. So, like for example, we have many techniques in differentiation, and you already did like maybe some questions related to that. You can scan which part that, okay, I can optimize my score here. So I need to make this priority. So I will consider this as my get to points. Okay. I think that will be helpful. Okay. If not, then yeah, it will be very difficult for you to get score. Right? And you need to be, again, like in the intro, you need to be smart. You need to be smart. Smart means that not every, like getting an A doesn't mean it's smart. Getting an A is just reflections on what you study, and that time your exam is fulfill some requirements for getting A. But it doesn't mean you're smart. It doesn't mean you're smart. But getting smart is optimize yourself. When you have a problem, you can solve the problem by knowing your own limit, your own weaknesses, and you can overcome. And that's smart. Okay, that is smart. Okay, let me explain this one. Okay, I think at least generally you will find 2 methods for this ln. Okay. So let me write down the first method. Okay. Okay, we see ln and we see some function. Okay, we do some ln derivative directly. That's okay. It's okay. So we take this derivative. So 1 over x e, and then let's say we write this as our chain rule. Now we have sometimes to walk through and take the product rule, right? So e with negative 2x plus negative 2x, and then e negative 2x, right? And then we have, this is 1 minus 2x. Okay. So we are going to get things down here, and we are getting that this is going to be 1 over x minus 2, okay, which is in our option, right? So this is similar to what we did in the log derivative. We take the log going down and multiply the chain rule, whatever chain rule we use. Now we have this product rule. We see x and e, 2 different functions. So we get the product rule, okay. And then solve some with algebra. This e negative 2x we can cancel, and then multiply, and we get the 1 over x minus 2. One way. Okay. I'm not sure which way you prefer, but the second way, I prefer the second way because it's much more clear and fast. Let me write a little bit to the right, to here. So let me write here, second way. rather than we take the derivative directly, we have ln, and remember that when we have ln, we can write as this. Okay? So, we first rearrange our equations. Okay? And then we take derivative. This will be plus 1 over okay, and then this will be canceling, and then you get directly I prefer the right one because we simplified the arrangement, and each separate functions becomes very easy to compute. Right? So this is also an advice. Whenever you find an ln and you feel that you need to simplify the process, you can separate the equations. Anyone yesterday using the second one? So I think it's also really good if you now, if you're having or facing with mathematical problem, calculus problem, usually in our minds before, we usually defeated by this question, our method. But now let's reverse that. Okay? We need to defeat the question. So before we solve the problem, we need to conquer what's the best way to solve, what's the fastest way to solve, so that we can be more familiar with the process. So as long as you, I think, give some time to practice, okay? At least like 5 to 10 minutes, like just one question every night or maybe every week. Maybe every week, maybe give 10 to 15 minutes to try by yourself, 2 or 3 questions. Randomly you can find in the internet. I think there's a lot of examples. You can find from the easy, simple one, and then going through the more advanced one. You can find and try. Okay? While waiting some question from you. Oh, by the way, to help you with the previous example, the related traits here, for the second question, a plane flying with a constant speed, passing the radar with some altitude, and it climbs at angle 30 degrees. So we can say, let me draw for you, and you can try to find by yourself. So let's say this is the plane. This is the radar. Let's say R. Like it has the radar like that, right? And it has 1, okay, for the height. And then it is going to climbs at angle 30 degrees. So because some of students ask me what's the best way to do it. So this is the 30 degree, okay, and it's asking
what rate is the distance from the plane to the radar station. So the plane is now here, right? Because it's already climbing. The radar station is in this arc. So the distance is going to be here. Okay? That's the questions mean. Okay. And to solve this,
Cosine theorem.
yeah. So the hint that I can give you is use the law of cosine. Law of cosine is when you have this triangle. This is, let's say, A, B, C, and this is C, A, B. Law of cosine is when you have C squared, A squared plus B squared minus 2AB cosine C. Okay. B squared is A squared plus C squared minus 2AC. And then A squared is B squared plus C squared minus 2BC. Okay. Yeah, you need to do some cosine. So this is your angle 30 and this is 90, so 120 you have. You need to find this distance and derive. Okay. So we can write with some symbols. We can write with A, B, C, anything. So let's say this is X, this is Y. Okay. So find some formulations. Put X and Y inside here, derive. And then after that, using the information from the question. The result is not really convincing because it's really messy, the numbers, but that's the result. Square root something, it has square root.
I got the answer. It's like
I forgot the numbers, but I know the fraction is 1,000 something over square root of 31. Yeah, but I think this is for, you can try at your home. I already did the picture and the formulation. You can try. But remember, the results, the number is not really good. Not really good number. Okay. Okay, I think the last 10 minutes, I will give you some intro for the linear approximations. That is supposed to be the last section in chapter 3. Okay, so we are going to finish chapter 3 on linear approximation. And also for the midterm, I think the safest way is the second week of November. Okay, second week of November. Okay. I think next week we can discuss the schedule. If you have any other exams, we can discuss. Okay. Let me continue for a while. Okay, continue for a while. I hope you've finished taking notes from this part. Okay. Let me go through some intro. Okay, linear approximation. Okay, let me give you a picture here. That we have, let's say, any random curve. Okay, let's say this is y equal f of x, and we have a point. Let's say x equal a. So this will be a point A and f of a, right? Now from our calculus before, the previous calculus, we can say that at this point A, we can also draw a tangent line, right? A tangent line. And we know the tangent line is actually
our derivative, the first derivative, right? The slope is our first derivative.
So let's say we have a slope and we have a tangent line that goes through this point. Okay, let's say we are having the tangent line. This is the tangent line. And remember that on the tangent line, the slope is actually f prime a, right? Now, of course, if we look
At the tangent line, it is just a straight line in our case here. Let's say the curve is a quadratic function, let's say polynomial with degree 2. If we see the curve and the tangent line, let's say we take some point here, we see some gaps, we see some distance, But when we take closer to this A, maybe here, you will see that the distance become very close. Very close. Okay, so from this point of view, for obvious reason, we can say that we can approximate when the value is nearby our actual tangent line. We can have some approximations. Okay, we can have some approximation for our curve.
Okay, remember that so let's say we have this, right? And at x equal a, we can develop our first derivative. This is equal f prime a, and this is equal to our limit definition. Let me write with this formulation for limit. Okay.
This is our definition, right? One of our definitions. The other definition we are using the age. Okay, from this, what approximations really mean? Okay, remember this is definition for limit. Approximations mean that our slope or our first derivative is approximating this fraction. So we can say
that this is our approximation. So f of x minus f of a over x minus a.
But of course, this approximation will be really close to the real number when it's close to the a. It may be nearby a.
Let me write here. This is true. This is correct when x is close to a. And then we can rewrite this and try to make our own linear equation from this. So we are getting fx minus f of a is approximating. So I'm switching right to the left and left to the right. Okay. And we get our f of x is f of a plus f prime a and then x minus a. Okay.
So basically this is just saying that the differences with this is the, remember previous limit, this is the secant line or the average speed if you relate to physics. So we can take this equally with this or approximately with this side. And then we can have our curve. So this works when you are not sure what the curve is, what the function is, but you can approximate with some value, and then you can find its derivative. So you can write down, maybe this linear equation will help to define our functions. Okay.
or perhaps you have some, let's say, some computations. For example, we have square root of 4.1. Well, of course, your calculators can compute it, but if we are just dealing with ourselves, the best way, we consider a function that is maybe equipped with this, and we consider when we have only 4, we get 2. Right? So let's consider that as our a, and the differences between this x minus a will be 0.1, and we can compute this with our calculus. At least it's getting close to the real value. And we will discuss this more next week. Okay? So this is the introduction. We can call also this is linearizations. We call this linearizations. This linear approximation, I think, really useful, helpful. After you get things through some, maybe later you have some analysis data, this is still powerful. It works similar with linear regressions. I think a little bit similar. Okay, we are going to continue next week, and I think on Friday I will give you some homework for chapter 3. So next week we finish chapter 3 and we move on to chapter 4. I hope chapter 4 can be finished faster, but if not, the midterm will only consist 3 chapters. But if chapter 4 included, it includes chapter 4. Chapter 4 is actually just application of derivative, how to sketch a curve step by step using calculus. Okay. Any questions? Any questions? Okay, if not, as usual, we are going to have a feedback. But this feedback, the question a little bit, 2 questions, but a little bit complicated. But so I think you need paper and pen if you would like, or maybe using your iPad to write. I think each question I give you around 4 to 5 minutes. So I think you need to have sometimes this. But it's doable. It's doable. Maybe it's a little bit long. A little bit long, okay? Yeah, question's still okay. I think question's still okay. Okay. All right. I think we can start. Okay, use your student ID, so I can easily assign your score. Okay, let's start. 3, 2, 1. Okay. Sorry. Where is Zoom? Okay.
inverse trigonometric to also have more examples, I think. Forget. You can check your notes. You can check
They are in paper.
Oh,
Oh,
okay,
yeah.
okay.
Sorry.
Derivative of tangent inverse x is 1 over 1 plus x squared. I give you something. Derivative of tangent inverse x is 1 over 1 plus x squared. I think if this is too small, I think you can focus on your screen. I think this is too small and a little bit blurry. Because I took it from somewhere else. I didn't have time to rewrite it. Push you to do this practice and
There's something wrong.
good exercise.
Yeah. Okay, careful. But I think, right or wrong, I think it's good exercise. Correct or not? Good exercise. Yeah, 75 seconds left. Okay, 10 seconds. I give up. I don't know how to.
Yeah. Sorry for the question, but I think it's good exercise for you.
Yeah. Oh.
Okay. Who is Maverick? Okay. Okay, one more. One more, get ready.
Checking your inverse trigonometry. You can check your notes. Next week we are going to have more review on inverse trigonometry after we finish the linear approximation.
cosine, and inside cosine we have sine inverse x. So derive cosine using the chain rule. I think should be okay. Compared with the previous one, it's more okay-ish. Supposed to be.
Yeah. I spent too much time. I just didn't realize. Yeah. I forgot the chain rule for the moment. Yeah. I think I will try to solve it again at home.
I think we decide it first, right? We decide it first, to derive. And this one, you derive completely. Cosine become negative sine, right? And multiply with this chain rule to the inside. Okay, good. Okay, Maverick. Good one. Okay. Okay, student ID and also feedback. I will explain again next week. This feedback.
Sorry, I have to rush.
Yes. So if you finish, you can go. Okay.